Hello everyone and welcome to another Thursday. It's going to be game development and we're going to mix a little bit of Unity and Blender this time around. And a couple of years ago I wrote a blog post about how early adopters your productivity will suffer, because I got really frustrated of having to do a lot of stuff in beta versions and in previews, and it didn't really feel fair. I had to spend so much time troubleshooting. Well, my productivity suffered. And then I realized, just as I looked at that blog post right now, I sound super old and I'm pushing mid-40s now. So I guess I should really brush that oldness off me and then dive straight into the new technology. So I'm installing Unity 2022, the latest beta version, and I'm also installing the latest version of Blender. And I'm going to create a low poly character, rig it, import it into the latest version of Unity, get the emissive material to work, get the correct rotation on the object, and we're going to get some AI stuff. Well, sounds complicated, but it's just going to be a nav mesh. The character is going to be animated and walk around on this little nav mesh. So stick around, have a look at this video, and let's enjoy it. I installed the latest version of the Unity Hub, which is 3.0 beta, to install Unity 2022, which is also the beta that we're going to be testing out today. I was happy to see that they've included some sample projects now, or templates, without the example assets, because last week I sent a tweet out saying that it was ridiculously large with 32,000 files for a brand new project. But still, even with the core templates now, they actually push in about 27,000 files. In the release notes, it said that they've been working on editor performance, and I was hoping that the starting of a new project, especially with the new core templates, would be faster, but it still takes a good 2 minutes to start a blank project up. So let's check out the file size for a brand new core project now without the example assets. We're still at 24,171 files, unfortunately. I also downloaded the 3.1 version of Blender. I thought, since I'm going full-on beta here, I might as well go alpha with Blender. So after installing that, I ran into some problems here, and I just set up my materials the way I used to do with a base material or a base color and the emissive texture. But no matter how much I tried to change the active texture in the shading editor, I just could not get the Blender interface to show me the texture in my viewport. It kept showing me the emission texture instead. And I actually reported a bug like this in the 2.8 version, so maybe that's a little bit of a regression on that one. I'll check again at some point, and if not, I'll have to bug report it, but I'll wait until the beta maybe. So I went back to Blender 3.0 and I followed my normal old modeling procedure. If you check out my channel history, you'll see that I've got loads of videos on how to model a character like this and how to rig it. And I followed that exact same procedure, and I made it to look a little bit cartoony again with an enlarged head and quite simple geometry. And I also wanted to add some emissive areas, so by the joints, by the shoulders and knees and through the waist, I added some indentations that I colored with a bright pink emissive color from the texture. If you followed my texture setup before, you'll see that on the left there, the texture looks all nearly the same in all quadrants. But the top left quadrant is just a basic color, whereas the lower right quadrant of the same set of colors are emissive. And the further to the left in one of those cells that I place my UV textures, the stronger the emission will be. So I followed the exact same procedure. Check out my tutorials and also some previous 10-minute modeling videos if you want to see exactly how you model a character like this. I'll also upload this one to my Patreon page. I'll put some music to it and just play it in real time because I've got screencast keys. So if you're a Patreon and the tutorial tier, you'll have a link there to see this one in without the fast forwarding if you're interested. I created a custom armature for this one, and I like to work with really simple rigs when I work in Blender if I'm going to use them in Unity. The fewer the bones, the more comfortable I am. So I created the minimum amount of bones that I could to control the spine, the arms, the legs, and then for the hand I just created a hand bone, a finger bone to control the palm, and then a single thumb bone so I could do some basic hand deformation. I suggest that you model your characters so they're facing forward in the positive Y direction within Blender. It makes it a little bit easier when you import them into Unity to use the bake axis conversion that they've implemented in later versions of Unity, so you don't have to work with quirky rotations. Unity uses Y up and Blender uses Z axis up, so there's always been a little conversion issue there when you import the armatures. So if you model them in the positive Y direction, import them into Unity and take the little bake axis conversion, then you're pretty much set to go. I went to the dope sheet and switched that to the action editor, and then I decided to create a few basic animations. First I created the T-pose and then a basic idle animation, and then I keyframed a walk animation. And I realized that it's been about maybe 8 to 10 weeks since I did a walk animation, And that's how fast I start to forget things, because I was feeling a little bit rusty there, so it took some extra time to get that walk cycle in place, but finally I got there. I went to File, Export, and I exported it as an FBX file into a new folder straight within the Unity project. I ticked selected objects and I changed Apply Scalings to FBX Unit Scale, and then I changed the forward to Y forward, and that automatically changes to Z up as well. Everything else should be able to be left as default. In Unity now, the mesh folder is automatically created, and I like the way Unity just automatically imports that mesh that was saved from externally. That's a really simple workflow that I like to use. I created a new material folder, and I dragged in my two textures, the base color and my emissive textures. And you can see that the emissive texture there has a lot of black in it, and that's because it doesn't light up any emission in those areas. I created a new shader graph. Last week we used the amplifier shader editor, which I actually like a lot more than the shader graph. But this week I was going to show you now how to do the URP shader graph. So I created a new one just called Common, because I tend to use the same shader and the same material for a lot of my low poly objects. That improves the performance. And once you've created the shader, it's available. So for my material, I selected that Common shader, and then pretty much good to go. And then you can double click on the shader itself, and that will bring you into the shader graph editor. And I find this one to be a little bit more complex and complicated, but I dragged my base color texture in and dragged the node there to populate it on the base color. And then I dragged my emissive texture in, and I did the same to the emission node. You have to click the little Save Asset button as well to save the shader. You can click the little plus button to create properties that you want to expose. And I create one texture 2D node, and I create one texture 2D property for the albedo texture and another one for my emission. And then you have to drag those properties into the graph and then connect them to the texture. And then I did the same for the emission. I dragged the property into the shader graph and then connect that to the texture 2D input node. Don't forget to save asset. And now when I select my material that uses that shader, I can drag my textures in. Even though I drag them into the editor, I still need to map them here for this very material. And then for the material, I actually need to change it on my character here in the scene as well. So when I drag my common material into the skinned mesh renderer node there for the material, it finally gets my little material onto it. And it doesn't look that emissive to begin with, and that's because we have to introduce a little multiplier, because by default the emission is only 1.0 and the scene is quite lit straight away. So we need to do a little multiplier there. To test it out, I just manually typed in to multiply the emission by 8 there. Later on I'll switch that for a customizable property so I can change it for the material instead. And there we go, with the 8 times multiplication on the emission strength, then it starts to finally light up. One good thing about the URP pipeline here is that the emission will actually automatically glow, because there's already a global volume in here with bloom enabled. Here we've got the rotation issue. If I pick the robot guy here, you can see that the rotation is -90 on the x-axis. And to fix this one, I need to go to the mesh that we imported, click on it, go to the model tab, and then tick bake axis conversion and hit apply. This way the rotation will be correct for the character, and it will face forward in Unity's forward Z direction. For the floor, I just create a new basic shape in Unity, a cube, that I position to the center, but I offset it down just a slight bit, and then I make it 20 by 20 units, so it's got a little floor to walk on. You can switch off these little gizmos if you don't really like the look of those icons, and I tried to switch off the actual global volume cube there that I didn't like, but no matter how much I tried to disable that particular icon, it didn't disappear, so in the end I decided to switch off all the gizmos. I don't know if it's a Unity 2022 bug or if I missed something else. I'm adding the animator component here, and that's required to get this character animated with those animations that we keyframed within Blender. I create a new folder in the asset structure here, and I just call it animators, and within that folder I'm going to create a new asset, and it's going to be a animator controller. If you double click on that one, you'll get into the node editor for the animator. And if I click on the mesh, I can click on this little expand button here, and then I see these animations. If I drag them, I can drag them straight into the animator. And we won't really need the T-pose, so let's get rid of that one, but I want the walk animation and the idle animation, and it defaults now to go into the idle animation. If I click on the mesh itself or on the FBX files, I go into the animation tab, and then I set the idle and walk animations to loop time. You can actually change both of those before you hit apply, and it seems like they've actually improved the speed a little bit about hitting the apply button. When I press play, nothing really happened, and it's because I actually forgot to map the animator into the game object component that we created. So in this hierarchy, I select the root object, and I drag my animator controller that I created into the slot there for the animator controller. And when we press play now, my character will go straight into the default idle pose. And in the scene view, we can have a little look around, and it's just standing there with a looping breathing animation. We don't have any movement set up or anything like that at the moment. In the main camera settings, you can go to environment, and if you don't want that skybox, I switched it to solid color and black as if it was in space. And if you go to the global volume, you can play around a little bit with the settings. Bloom is already enabled by default, and you can change the intensity if you want. And you could also change it by adding to the multiplier that we created. In the scene view, we can also disable the skybox if we don't want to see that one in there. I added a new property called emission strength here, which is a float. And then instead of having a fixed value, I can drag that property in and have that control how strong the emission should be. And by doing it this way, we can actually change it from the properties of the material itself. If I select the material now, the emission strength variable is exposed, and I can just click and drag on that one, and that affects the multiplier, so it'll change the strength of the emission for this material. Let's get into the final part of this video where we'll have this character walk around a little bit using, I don't know, AI is a bit overkill to say maybe. But if we go to Window and then under AI, click on Navigation. And then for the object, we've got the floor selected there. I'm going to click Navigation Static. And by doing this, I can go to the Bake tab and click Bake, and that actually bakes a navigation mesh for this character to walk on. I clicked it a few times because I couldn't see it, and it bit me a little bit because I had disabled the gizmos before that we were talking about. So when I enabled the gizmo again, I could see this blue area, and that's the automatic nav mesh that it's created for this character to walk on. I right-click under Assets and I create a new folder, and let's call it Scripts. And then in the Scripts folder, we'll create a new script, and I'll just call it Character. When I double-click on the script, it'll open it in Visual Studio so we can edit it. Let's create a private variable here to the nav mesh agent, and you have to press Ctrl- on your keyboard to add the Unity engine.ai using reference there. And in the start method, we can grab a reference to that nav mesh agent, and we haven't actually added that one yet. So let's go back into the hierarchy, click on the game object, and add the nav mesh agent component. Now in our script, we can actually use this reference to set a new target for this to walk to. To do that, I type navmeshagent.setDestination, and that takes a vector3 input, and we're only operating in the X and Z plane here for width and depth. So I'm going to do a random range between -10 to 10 in the X direction. Y is going to be 0 because we're not doing up and down yet. And then in the Z direction, which is the depth, we're going to do random range -10 to 10. When we press play now, it's just going to set one destination in the start method. So this character is going to get a random destination to go to. We haven't set up the animation yet, so it just slides to the position. In our script, we can break this out into a new method instead so we can reuse it. So let's create a new method called setNewDestination. I'll copy the code that sets the destination, and we can call this at any point. And then let's still call it in the start method so it actually gets an initial destination to go to. The update method is called every frame in Unity, so let's check if the navmesh agent has a distance remaining which is less than 0.2, for example. And if it is, then we're going to set a new destination. I don't want to put 0 there because maybe it doesn't actually reach the exact position. So let's make sure that we just have a little bit of a buffer there. Now when I press play, we're going to have this character slide into a position, and when it reaches that destination, it's going to be going to the next one and the next one. And we can see here in the scene view where I get some rotational freedom that we can see that it just gets new locations every time it reaches near its destination. Since we created a walk animation, we should get that in here too. So let's go into parameters in the animator and create a new parameter called speed, which is a float animator. We'll create a transition here and add a condition where speed is greater than, it's greater than 0 by default, but we're going to change that to greater than 0.1. And then we're going to transition back if it's less than 0.1. We don't want to operate on exactly 0 here because it's not going to get less than 0. I have to untick has exit time on both transitions, otherwise it's going to wait for a full loop cycle of the animation before it transitions, and we want it to transition straight away. To set this parameter now, I need to grab a reference to the animator, so let's create a new private variable and call it animator, and in our start method I'll get that component reference to the animator. And now in the update, we'll just continuously update it with the speed from the navmesh agent. So I'll do animator.setFloat, and then the name of the parameter is speed, and then we'll just set it to the navmesh agent.speed. Now when we press play again, it'll just feed the navmesh calculated speed here and bring that into our animated character, and he'll start to walk as he transitions. Maybe there's some fixing to be done in terms of how fast the angular speed is and if the animation syncs up decently enough with the speed. We can change that by multiplying the speed in different ways. If I go to the navigation tab here, we can see that it's navigating within this baked nav mesh that was created before. Let's create some more obstacles. So I'm going to duplicate this object here in the editor. So let's make a few copies of it and change some scales. I'll just use the same basic cube and replicate it over and over again a few times. It's already got the navigation static setting, so when I make duplicate copies of this floor cube, it'll already bring that along with it. But I still need to bake the whole nav mesh once again when I'm finished. I'll also create a little slope here and some obstacles that they have to walk in between. You can configure the slope factor of the nav mesh, and you can also change the agent radius here. So if I change this to 0.2 and then click the bake button again, it'll give us a little bit more allowance to go between those pillars. Now our character keeps getting new random locations, and he can walk between the pillars and up and down slopes and take a few small steps. There's a step limit as well to where you can configure how big of a vertical step the character should be able to make. Let's go into the animator and change the inspector value here for the speed parameter. I can, instead of having that fixed to 1, I can set that to be multiplied by our speed parameter. If I press play now, he's actually walking a little bit too fast because it's taking the speed of the navmesh agent and piping that directly into the animation speed. So we have to change the multiplier a little bit, and this you can change while the whole game is running and it's persistent. So let's change the speed to 0.2 first, and that's too slow. So let's bring it up to 0.5 and then multiply that by the speed parameter there, and that seems to be a pretty decent compromise. The good thing is that you can see the parameters to the left down in the animator as well. We see that the navmesh speed is set to 3.5. Let's change the angular speed for the navmesh agent, and here you also have some different settings for stopping distance and acceleration, and the top speed and the radius of the obstacle avoidance that you can play around with. Let's press Ctrl D on this character a few times. And the beautiful thing is that the component, the navmesh agent, and the script that we created is also duplicated in the process. So we can just do these and they'll independently pick new random destinations when we press play here. And then they should decently enough avoid each other as well, so they don't walk through each other. The navmesh avoidance is built into the Unity AI navigation system. Let's make some more copies. We can do that during runtime. That won't be persistent, but let's make loads of copies and see how it works. They're not walking through each other, but it does get a little bit congested, and they're all in the same sync near enough with their walk cycle. Well, not quite, but not far off. So maybe we could have given them some random speed parameters and random angular speeds. Every time you press play and start and stop the game, it's a little bit slow, I think, and even though they're supposedly fixed that speed a little bit, you can go into the editor setting and click this little enter play mode options, and that way you can temporarily at least disable the reload of the domain and the scene, and disable the backup if you want to go fast in and out. So when you press play now, Unity crashes. So make sure that you save before, especially since you disabled the automatically save scene. But I think so be a little bit aware of this. Maybe it's because it's a beta version, and maybe you should be very cautious about using that one. But if you're prototyping stuff, especially early on, and you don't require the scene reload, then changing that will significantly speed up the way you can go in and out of play mode. It's pretty much instant in that case. But be aware, if it starts to behave a little bit funny or weird, then you should probably re-enable that one at some point again. So we got ourselves a little character modeled and rigged inside of Blender 3.0. And then we imported him into Unity with the correct rotation, got the shader graph in the URP pipeline to set up so it renders the emissions correctly and has that bloom effect. And then we added this little AI navigation component so the character can walk around to new random locations. Thanks a lot for watching this video, guys. I hope you enjoyed it. Give it a thumbs up if you did, and don't forget to subscribe. And I hope you have a great Christmas now, and come back next Thursday just before the new year, and we'll get some more game development stuff done. Until then, take care. And bye for now.